Good day, everyone. Welcome to our math talakayan about sets and operations on sets. In this video, we are going to discuss the different terms related to sets. Tara na at matuto! As we go on to our discussion, I hope that you have with you your pen and your paper so that you can take down notes the important details of our lesson. Our lesson for today is one of the lessons from Math Grade 7 entitled Set as All. For our objectives, at the end of the lesson, the students are able to letter A, describe and illustrate well-defined sets and determine the cardinality of a given set. Letter B, use a Venn diagram to represent sets. Letter C, perform the set operations. What is set? And what comes to your mind when you hear the word set? Set is defined as a collection of a well-defined objects or things. Examples like set of yellow foods, set of fruits that are red in color, set of pens, or flock of birds. Can you cite other examples of set? A set is said to be well defined if a given object belongs to that set. Examples: a set of numbers, a family of plants, a set of mathematical books in the library, a set of appliances both in a store. So these are examples of sets given. How do we name sets? So sets are named by any capital letters like the letters illustrated. So we have capital A, B, C up to letter Z. How about small letters? Small letters as A, B, or C, as shown in the figure, is used to denote the elements of the set. Next, the cardinality of a set is a measure of a set's size or the number of elements in the set. A cardinality of a set A is written as n and then parenthesis capital letter A for set A and then close parenthesis. So let's have example number 1. So example number 1, we have set A equals the open parenthesis 1, comma 2, comma 3, comma 4, comma 5, and then close parenthesis. Or this can be read as set A is a set of numbers 1, 2, 3, 4, and 5. Or set of numbers or set of counting numbers from 1 to 5. That means set A is a set of numbers. And 1, 2, 3, 4, and 5 are the elements of set A. Again, capital letter represents set, while small letters represent elements of the given set. If not letters, then they are numbers. And the cardinality of set A is equal to 5 because there are 5 numbers in set A. Let us proceed now to example number 2. So example number 2, we have set B is a set of numbers with elements 1, 3, 5, and 7. Will you describe the elements of set B? Correct. Set B is a set of odd numbers. 1, 3, 5, 7 are elements of set B. And the cardinality of set B is equal to 4. Why 4? Because there are four numbers inside the braces, or there are four numbers in the given set, and that is 1, 3, 5, and 7. Another example, let's discuss example number 3. So set C equals 2, 4, 6, 8, 10, and 12. Class, will you describe the elements of set C? Excellent. Set C is a set of even numbers. So we have 2, 4, 6, 8, 10, and 12 are the elements of set B. How about its cardinality? How many elements in set C? Will you count? So we have 1, 2, 3, 4, 5, 6. So therefore the cardinality is 6. Next, example number 4. Set D equals elements of H, U, M, I, L, T, Y. Yes, class, you see it right. The given elements of set D are letters. Can you form a word out of this set of letters? Yes, so set D is a set of distinct letters in the word humility. Set D is a set of distinct letters in the word humility. So if you are going to observe, letter I was written once only, and it is not repeated. That means in a set, elements must not be repeated. Therefore, the elements of set D are H, U, M, I, L, T, and Y. How about its cardinality? Very good. Cardinality of set D is 7. Let's have the last example for this. So we have example number 5. So set R is a set of colors. We have red, orange, yellow, green, blue, indigo, and violet. Will you describe the elements in set R? Very good. So set R is a set of colors in a rainbow. Or we have the rainbow. Okay, so we have red, orange, yellow, green, blue, indigo, violet are elements of set D. And how about how many colors were mentioned in set R? Or we are referring to its cardinality. So the cardinality of set R is 7. Okay. A set with no members is called empty set or null set. It is denoted by this symbol. So we have here braces or the Danish symbol letter. So we have like a circular, or we have O and then slash. So we have the Danish symbol for null set. For example, in example 6, we have set Z equals and then parenthesis only. So what does it mean? So this set Z has no element, or the cardinality of set Z is 0. Next, a set with only one element is called unit set. Example number 7. Set G equals apple. Obviously, set G has one element, and that is an apple. Therefore, the cardinality of set G is equal to 1, and that is called unit set. Now, let us proceed to Venn diagram. So, what is a Venn diagram? So, these are diagrams that makes use of geometric shapes to show relationship between sets. Geometric figures such as rectangles and circles may be used to represent sets. Such figures are called Venn diagrams, named after the English logician James Venn. James Venn. So that is Venn diagram. Okay, next we have universal set. Okay, Venn diagram was shown in this figure. Venn diagram were used to in this illustration. So rectangular shape shows a universal set. And what is universal set? So universal set contains all elements being considered in a given situation. So using this illustration, a rectangular figure represent a universal set. So represented by capital letter U. And then circle represent a set named as set A. So what does it mean? Set A has two elements, so that is 3 and 6. But when we talk about universal set, all the elements were counted. So therefore, universal set has elements 1, 2, 3, 4, 5, and 6. Okay, let us proceed now to our subtopic. It's all about operation on sets. So under operation on sets, we will discuss about intersection of sets, union of sets, and complement of sets. Again, intersection of sets, union of sets, and complement of sets. So first, the intersection of sets. Look the given illustration of intersection of sets. What do you observe? So, what is intersection of sets? What do we mean by intersection of sets? So, intersection of sets, we have set A and set B written as A, and then we have the inverted U, and then set B is the set containing the elements that are in both set A and set B. Again, both in set A and set B. To illustrate, okay, we have here the representation of intersection of sets shown in the Venn diagram. So we have set A and then set B. So all the elements inside the color red part are elements present in set A and set B. So we have the Venn diagram, and then if you are going to write that in symbol for the intersection of set, we have A and then a symbol for intersection and then set B. Okay, let's have an example of intersection of sets. So we have set A has elements of 1, 3, 5, 7, and 9, while set B has elements of 2, 3, 5, 7, and 11. Okay, again. So first that you are going to do is to draw a rectangular figure and write capital U in the upper right side. This is to represent the universal set. Next, since there are two sets given, set A and set B, you need to draw two circles inside the universal set. So as shown in the figure. Next, look at the two sets given. So spot the similar elements or the same elements, and that will be written at the middle where the two circles coincide. So we have here, okay, so we have 3, 5, and 7. So 3, 5, and 7 are both elements of set A and set B. So after that, write the remaining elements that belongs to set A and set B. Therefore, the intersection of sets A and B equals 3, 5, and 7. Again, the elements that are common to both sets is their intersection. So our final answer here is set A intersection set B equals the elements of 3, 5, and 7. Okay, so another example. So similar example, for example 1, the intersection of sets. So set A, for example 1 is, and set B has intersection with the elements 3, 5, and 7. So these two sets are also called as joint sets. Joint sets in the sense that they have their common elements. But in example number 2, if you are going to observe, there are two sets. We have set A and set B. So do they have common elements in set A and set B? Okay, there's no common element. So therefore, set A intersection set B is a null set. Okay. A null set is a set that has no element. Since set A has no intersection with set B, then these two sets are also called disjoint sets. Okay, disjoint. They are separated with each other. Again, for the joint sets, they have their common elements, while for disjoint sets, they don't have the same elements, or these two sets are null set. Now, let us proceed to union of sets. So, what is union of sets? The union of sets A and B written as A and then capital letter U for the union and then set B. So it is set of all the elements that are in set A or in set B or in both set A and set B. Again, elements that are in set A or in set B or in both set A and set B. To illustrate, we use a Venn diagram again. So observe the two sets, set A and set B. For the elements of two sets, when we say union, we are going to unite or make as one set. Or in other words, all the elements are included. Okay, so let's have an example of union of sets. So given set A has elements of 1, 3, 5, and 7, while set B equals 1, 2, 3, and 4. Again, using Venn diagram, draw a rectangular figure to illustrate the universal set, and then draw two circles to represent sets A and B. Next, look for the common elements, and that will be written where two circles coincide. So the common elements for set A and set B are 1 and 3. Next, write the remaining elements inside the circle for this which belongs to set A and set B. For the union of two sets, set A and set B, we can write this as set A union set B equals set of counting numbers from 1 to 7. So we have 1, 2, 3, 4, 5, and 7 are the elements of um, set A union set B. Next, for the last set operation, the complement of sets. So the complement of a set A written as A and then apostrophe. So is the set of elements in the universal set that are not in set A. Look at this figure. So outside the circle or set A, we have A prime or the complement of set A. And complement of set A is still part of universal set. Let us discuss the given example using Venn diagram. So the given universal set has elements of 1, 2, 3, 4, and 5. And if set A equals to 2 and 4, or the elements of set A is 2 and 4 only. So what do you think will be the complement of set A? To be able to know the answer, we illustrated this using Venn diagram. So write first the elements of set A. Then all the elements that do not belong to set A will be written outside set A or outside the circle. If the universal set has elements of 1, 2, 3, 4, 5, and if set A is equal to 2 and 4, then the complement of set A has elements of 1, 3, and 5. Again, all the elements outside set A will be the complement of set A, and that is 1, 3, and 5. Okay, so I hope you have learned a lot about sets and operation of sets regarding Venn diagram, the joint sets, the disjoint sets, the union of sets, intersection of sets, and complement of sets. For the values integration, we are going to apply set, identify your set of priorities in life. So what are your priorities in life? Maybe it is written, or you are going to think and you are going to identify it by set or by group so that your priorities in life will be fulfilled and it will become successful. So that ends our discussion about sets and set operations. I hope you've learned a lot from this video. Thank you for watching and try to subscribe if you want. Thank you.